Welcome students. Today is the 29th class on digital land surveying and mapping. In this class I will discuss about the basics for vertical presentation. Now you know the basic objective of surveying is to prepare plan or map. Now in civil engineering or many engineering works, the plan or map is required also for to know the nature of terrain on which the engineering project is to be constructed or taken into consideration. But since the map is a two-dimensional paper, so and the relief or the variations in topography has to be in three-dimensional view, so there is a problem in depicting the three-dimensional object in a two-dimensional paper. So there is a specific way how to represent the three-dimensional view of the earth surface on a two-dimensional paper. So in today's class I will introduce to that portion of the mapping work. Now the core today's class will be discussed under these following heads. First I will introduce, as I have already told, and then vertical representation fundamentals, and there is a specific word called contour interval which is very important to know and to be discussed in detail, and some of the characteristics how the representation has to be done we have to discuss. Now the utility of any plan or map of an area increases as we also depict the relief or the nature of terrain of the topography. Now to that means we are in need to represent the 3D surface of the earth in a 2D paper, and this is done or can be done in a different ways. There are many methods how it can be done. However, in case of civil engineering work or engineering map or topographic map, we call it, there is a specific way, or we do represent the relief of the terrain in a specific way, that is what is called contour. That means contours actually are some representation which provides us the elevation and its quantitative value at any point. So we will not only get the elevation or the nature of the terrain, but also we will get the quantitative value of the height at any particular point at which contour we can have. So we make use of contour for representation of height or the relief of the terrain. Now we will discuss about the contour. The third dimension of the terrain is being represented in a plan or map through contour. Now what is contour? Actually contours are the lines, or you can say imaginary line, which represents the line having constant elevation. That means if we say this is a contour, then we will understand that the points along this line, all points on this line will have equal elevation. So other way, if we say that a line having equal elevation at each point is called a contour. So either way we can say that contour is a line of equal elevation, or a line joining points or stations having equal elevation, we can get a contour. Now this is what is the definition, but physically we can say like that, it is the intersection of the surface of the earth with a level surface. So the line of intersection, suppose this is the surface of the earth, this is the surface of the earth. Now if we imagine some level surfaces like this, now these are the level surfaces, level surfaces. Now if we imagine from top, then we will be able to feel that, because this is a three-dimensional object. So if we imagine from top, then there will be corresponding to this point and the area, there will be a line like this. So corresponding to this, again we can have a line like this. So you can see that the intersection of the level surface and the actual surface of the earth will provide us a line, and this line will be of equal elevation. So now this line will be having, suppose this is a level line at 100 meter, and this is a level line at 90 meter, and this is a level line at 80 meter. So I can say that the elevation along all throughout line is 100 meter. So I can say that this is a line, this is a contour of 100 meter. So the intersection of a level surface with the actual surface of the earth provides us a line. That line is termed as the contour. Now this is very well, we can see whenever there is a pond, you will see there is a pond. You will be see, if we see a pond, then there will be a water in the pond, and if it is still water is not moving, still water, then this water surface will be intersecting along the periphery of the pond. Along the periphery of the pond we will get a line, and this is also a contour line. This is a line having equal elevation, so this is a contour line. So this is the most familiar or widely available contour line that we can easily see if we go to near to any pond, and if the water is in still condition, then that water will be meeting its periphery, and the line joining that periphery is the contour line. So this is, most of you must have already come across, or you can see around. So contour is a line joining points having equal elevation, and contours on the ground. Now this is the contour, this is the ground, and this is the line. Now if I draw this in terms of a map, then that is called contouring. So drawing a contour line in a map is called contouring. Contouring is the process of drawing contour lines in a map. So in case of preparation of plan or map of any area, so we should go for contouring, means we have to adopt some methods, or we have to do something to observe the data from the field to in the field and to download the data and process the data and convert the data to draw lines of equal elevation, and that is what is called contouring. That means through contouring we will be able to provide the variations in height of the surface of the earth, or we also can say that we will be able to depict the relief of the earth surface along with its quantitative value. Now there are different way how these contours has to be depicted, how this contouring is to be done. Now as we prepare a plan or map, always we do go for a scale that is called horizontal scale or scale of the map. That means the scale representative fraction by which we do represent the location of any point, that is planimetric position of any point. Similar to that, there is a concept, because we are representing height using contours, so we need to have a scale for representing the height or contours. So, and that is what it calls contour interval. So, contour interval is a contour interval actually it is the difference in height between two consecutive contour line. So now in this case, if I take the level surface at 80 meter, 90 meter, 100 meter, so the contours that we will get in this case will be the inner one will be our 100 meter, then 90 meter, then 80 meter. So here you can see that the contour interval is 10 meter. So contour interval is the amount of difference in contour value between two adjacent contours, and that is the representation of vertical scale of a map. Now this contour interval actually represents also the accuracy in height. That means it is the half of the contour interval represents the standard deviation in height which we can permit. So I can say that when there is a contours 80 meter, 90 meter, 100 meter, then I can say the measurement of height is having an error of plus minus 5 meter, which is contour interval divided by 2. So contour interval also provides us the accuracy in height measurement or height representation. Another point is that contour interval, like our linear scale for planimetric positioning, the contour interval also has to be fixed for any map. In any map we must have a single contour interval. So contour interval is a very important parameter in case of a map preparation to represent the height. Another point is that contour interval varies to the scale of the map. Now I will be talking on some other factors on which contour interval of a map depends. Now the actually contour interval is a very important parameter for representing the 3-dimensional topography on a 2-dimensional map, and we have to choose contour interval very judiciously. And however, there are 4 main considerations under which we do decide about the contour interval of any map. As we already told, contour interval of any particular map is fixed and it represents the vertical scales, thus the accuracy in representation of vertical height. So we have to be very much cautious in deciding about the contour interval of any map, and contour interval of any map is based on 4 primary criteria apart from many other criteria. First one is that accuracy. Now accuracy from two considerations: accuracy from the consideration of map preparation and accuracy from the consideration of data availability. Now let us consider on the map consideration. Means the accuracy of the map will depend upon the purpose for which we will be using the map. Now there are two types of fundamental use of height of the map. One is for design purpose and another is for location purpose. Now when the height from map will be used, will be used for design purpose or for earthwork purpose, we need to have a very accurate, means quite accurate height value, and for that we need to have our contour interval very small as possible. So that means we should have the contour interval very close to each other. Contours should be having very close to each other, so that the error in height will be less, and that will lead to less error in design parameter as well as computation of earthwork. And on the other hand, if we make use of the map for location purpose, we do not need much accuracy in height, so we may afford to go for more contour interval, means or higher contour interval. Now also the data. Now as we know that contour interval represents the accuracy in height, so with what accuracy we will be measuring the height, or what is the accuracy of measurement of height. Depending upon the accuracy of measurement of height, we have to take the contour interval. That means if the accuracy is measurement of in height is suppose 1 meter, accuracy in measurement of height in 1 meter, so we cannot go, that means our standard deviation can be 1 meter, so we can go up to 2 meter contour interval. We cannot go less than that, because half of this is the error in accuracy. So after getting, or if we say that we want to have a contour interval of 0.2 meter, so we must go for measurement of having the accuracy of 0.1 meter. So in that way we can guide our survey work, or from the measurement already done we can also decide what should be the control point. Now for the next category is that nature of the terrain. Now in case of nature of the terrain, generally we do take the contour interval higher as the slope is more, so that the number of contours that is available in the map is fairly distributed, and the other objects or features can be seen quite clearly. And then the third one is that legibility. So as I told you that the number of contours in the map should be such that it does not cover the other objects present or object presentation. So as I have told in nature of ground that the number of contours should be inversely proportional to the slope. Higher the slope, larger the contour interval. So because if the contour interval is more, then we will get less number of contours for the difference in height. Further, the another important point is that time available and cost. So if the time available is less, then we have to go for larger contour interval, because that will lead to less amount of data and less amount of survey work. So and also the cost will be less. So If the time and cost are less, then we should go for larger contour interval. Otherwise, if we want to have the contour interval small, then the time involved and cost involved will be more. So these are the criteria which we do take, and while we will be deciding about the amount of contour interval for any map, and which is nothing but the vertical scale of the map. Now here some of the representative value for the contour interval, that if we want to go for construction of building that site and the scale of map is 1:1000 or less, that means larger scale, then our contour interval we should take from 0.2 to 0.5. Now if we go for town planning or reservoir construction, then we will like to have our map in the scale of 1:50,000 or 1:100,000 or 1:10,000. So then contour interval should be 0.5 to 2. When you go for location survey, and if the scale is 1:10,000 or 1:20,000, then our contour interval can be 1 to 3. So depending upon the purpose, also our scale varies, also contour interval. So actually contour interval is the vertical scale and this is the linear scale, planimetric scale. So we can see that if the planimetric scales are larger, then our contour interval should be less. Similarly, another way how we can classify about the vertical scale or which is contour interval is that what is the map scale means our planimetric scale is large. For different types of terrain, contour interval will also vary. Now you see for some same scale, if the terrain is having higher slope, then we will have contour interval larger, as I already told that hilly terrain will be having more slope than rolling terrain will be more slope than the flat terrain. So the contour interval is directly proportional to the slope. Higher the slope, contour interval should be more. That will help us to minimize the number of contours in the same amount of mapping area. So that means you see our contour interval varies from 0.2 to 2 depending upon the type of terrain for a large scale, and it varies from 0.5 to 3 meter in case of intermediate scale, and for small scale it may vary from 1 meter to 10 meter in case of small scale, and for mountainous terrain the contour interval may be 10 meter, 25 meter or 50 meter. So this is very important to decide about the contour interval when we will be preparing the map, because this provides us the accuracy of height measurement. Now next point is that after deciding the contour interval, we have to go for contouring. That means we have to draw the contours. Now to draw the contours, we need to follow some characteristics of contours, and we need to know some point which will help us to draw the contours properly, and so that the contours represent the nature of terrain properly. Of this we need to know first that the variation in vertical height between any two contour line is assumed uniform. So if I say this is a contour, this is another contour, now between these, suppose this is a contour of 10 meter and this is a contour of 20 meter, that means the height is increasing. So if we take a line along this, then we will assume that the slope of this is constant. So this is a very important thing we have to remember, and the slope is represented by the distance. Now you see, if we say along this line the slope is constant, along this line also slope is constant, but the amount of slope from this point to this point and the amount of slope from this point to this point along this line will be different depending upon the distance. If this distance is suppose 5 centimeter and if the same distance is 8 centimeter, now you can see that for a 8 centimeter distance the difference in elevation is 10 meter, whereas in this case for a distance of 5 centimeter in the map the slope is the vertical distance is 10 meter. So this slope along this line will be more than this. This is what it is written here, that horizontal distance between two consecutive contour varies inversely among the slope. If the horizontal distance is less, then the slope is more. If the horizontal distance is high, then slope is less. Now how we do represent the different types of terrain. Now if the terrain is flat like this, so in this case our contours will be very highly spaced. Now if the terrain is uniform slope, now you can see suppose this our contour will be spaced like you see. I will, if I say this level lines, they will be equally spaced, so our contour line will be equally spaced. Now if the steep slope, so if the slope is very steep, so as you can see that the our level lines, suppose this is 10 meter, this is 8 meter, this is 6 meter, but in this case the same distance will be your 6 meter, this will be 12 meter, this will be 18 meter, this is 24 meter, because slope is very high. So our for the same distance it will be more height. So steep slope we will have the contours. Now if we see this thing like this and like this, now we can say that suppose this is your 5, 10, 20, 25, 30, 35 meter, 5, 10, 20 meter. So this is the area where slope is very steep, because for the same horizontal distance our difference in height is more, whereas this is a less slope because the horizontal distance will be more, having the same change in height. So in steep slope the we will represent through very closely contours, and for flat terrains or less slope the contours spread widely. Now the steepest slope of terrain is represented along the normal. Now if this is the contour, what will be the, at any point, what will be the steepest slope? So if we draw a normal to that, that means drawing tangent to this and not, that means this is the direction where we will get the steepest slope. So for steepest slope we must have the steepest minimum radius of curvature of the contour. Now if there is some depression or hills in a terrain, how we, suppose I have a like this, suppose this is the water, and then this is the hill. So for the hilly terrain, so what we do, we do take level surface like this. Now you can see, if I say this is our 10 meter, 20 meter, 30 meter, 40 meter, 50 meter level surface, so corresponding to that we can draw this figure, and this is suppose 60 meter. So if we draw like this, so you can get the 60, 50, 40, 30. Also in this case also we can say this one. So here is also like this, here it is suppose 0 meter. So now both in the, whether it is a hilly terrain or whether it is a depression, in both cases we get a concentric rings of contours 0, 10, 20, 30, but in this case the value of the contour is increasing towards the center. in this case value of the contour is decreasing towards the center. So, both the depression, both hills as well as the depression we represent it through concentric contour lines, but in one case it is the increasing inward in case of hilly, and in case of ponds the value will be decreasing towards the center. So, in that way we can we do represent different physical surface of the earth in a different types of contours. Now, if there is a cave or overhanging cliff, we will have contours at different elevations, but there will be some crossing each other. Now, if there is a vertical cliff, the contours at different elevations united. Suppose this is a vertical cliff like this. So, like this, if we now here you can see this will be if we draw the contour, then we will get like this. Like this. So, in this here there will be contours will be joining, and from there we will be able to understand that this is the vertical cliff. Now, contours have valley lines and ridge lines. So, in case of hilly terrain we will get valley line. So, valley lines will be represented by this inverted towards uphill. So, I can say this will be valley line. So, this is our 30, 300, 290, 280 meter. Now, for ridge we will get the inverted U-shaped line, and this is the line of ridge line, and this is our 300, 290, then 280 like this. So, this is our ridge line, and this is our valley line. So, valley line can be represented by using inverted this contour line to pointing towards uphill, and inverted U line also pointing downhill. So, in that way different types of physiography feature can be represented using contours. With this I like to conclude today's class. I like to summarize this, that the relief of terrain is represented by contours, and contour interval represents the vertical scale of the plan or map. Also, contour interval provides us the accuracy in measurement of height, and the contour interval has to be decided depending upon the accuracy, terrain condition, legibility of the map, and time and cost available. There are some standard contour intervals available in practice depending on the purpose and nature of terrain, as well as scale and mapping. To represent different types of terrain, different characteristics of the contours has to be kept in mind and during its depiction. With this I like to conclude today's class. Next class I will be talking on contouring.